All right, we're going to demonstrate the dilution process from a standard stock solution. What I need to do, first of all, of course, make up a standard solution. And so I'm going to use copper 2 sulfate, that's this compound here, and I'm going to make 100 milliliters of a 0.3 molar concentration. That'll be my standard solution. I'll leave you to do the calculation for how much CuSO4 5H2O copper 2 sulfate pentahydrate we need. And then what I'm going to do is take 25 milliliters of that to make a 100 milliliters of a 0.075 molar diluted solution. Okay, so let's get started. The first thing we need to do is mass out the amount that I need for my copper 2 sulfate. So that's this stuff here. I've already done the calculation, so like I said, I'm going to leave that calculation to you. All right, there we go. That's good for that. And so now that's going to go into my volumetric flask. And now I'm going to add distilled water to that in order to get the solution made. Now the first thing that I'm going to do is I'm going to add some water and then swirl that around to get the solid to dissolve. And because it's a fair bit of, it's actually a fairly high concentration of this stuff, this may take a while to do, so I'm going to probably trim the video at this point, and you may see some edits along the way. Okay, so this has had time to dissolve now. We will add a little bit more water to that. And so what I want to do is I want to add water so that it's not quite into the neck. And then just make sure every last bit has dissolved. And we're pretty good there. Okay, so now we have to get the volume of water just right. So that means that it has to go up to, see the mark that's in the neck of the glass where my thumb is? That's where it has to get to. Now the best way to do that is to either bring the flask up to you, or because it's sitting nice and level on the table here, lower yourself down so that you can see the line here. All right, I'm getting used to my new trifocals here, so I have to find the right spot. Okay, so what I'm going to do is just add water now. Slowly bringing it up. Oh, there it is. There we go. Okay, so I'm going to bring this closer to the camera. If you look carefully, you can see how the surface of the water kind of bows up on each side of the neck of the bottle. All right, you'll notice that the bottom of that is sitting on the line that's engraved. All right, that is called the meniscus, where the water bows up like this. And so the bottom of the meniscus has to be right at the line level, and then you know it's the right level. Now, just to make sure that this is done right, that's the technique, and get rid of the bubbles. And again, there you see it's sitting right in the right spot. Okay? Okay, so now what we want to do is we're going to take that solution and pour into a beaker because I need this volumetric flask again. Let's pour it into the beaker. All right. And so at this point, what we're going to do, and I did these calculations on purpose like this so that I can take exactly 25 milliliters and pipette it from here back into the volumetric flask, add water to the mark, and then so this is a 25 milliliter volumetric pipette. It's graduated, you can see the mark here, graduated to exactly 25 milliliters, plus or minus 0.06 milliliters, okay? So that's the precision on this. I'm going to use two hands to do this transfer. I'm going to use this pipette bulb to do that. So the top valve here lets me let all the air in the bulb out. The lower one lets the air back in and creates the suction to pull it up. So that's why it's labeled S. And then the one at the side here is if I go too high, I need to let some air back in so that the level drops, and that's what the evacuation, the E valve, is for. So this goes on to the end of the pipette just so that it makes a seal, okay? Not jammed on there so that it actually causes damage to the valves inside or anything like that, or you can't get it off again afterwards. So just enough, because to allow all the stuff to drain out of the pipette, it's actually easier just to pop this off. And so we just want to make a seal and nothing more. The top hand controls the valve, the bottom hand controls the tip. The bottom hand is going to rest on the beaker, and so that the tip is in the solution but not resting on the bottom of the beaker, okay? If you're resting on the bottom of the beaker, the tip might break, and that's not good. So we'll draw the solution up, and this usually takes a bit, and then we'll need to get to the level of the line again, and the same sort of deal, the bottom of the meniscus has to be on the line, and I've gone over and back down, back up again. This usually takes a bit of skill. Oops. There we go. And we're going to transfer that again. You'll notice two hands. The tip is controlled with the bottom one. The bulb is controlled with the top hand. And I'm kind of holding everything together again so I don't tip anything. Out of the way. Okay, so that'll drain down. Okay, now you'll notice that there's just a little bit of solution left in the tip. That's okay, the calibration is based on having that there. Don't blow air into it to get rid of that, because then you'll actually have a little bit too much. All right, so now we just add water to the mark again. And there we go. This is where you have to be very careful, because if you go over at this point, you start again. You can't take some water out without taking some solute out with it. So always make sure that you're very careful on that last bit. I made it look a little bit easy, but I've been doing this for a few decades now. So, all right, so there's the mark. It's ready to go. Again, proper technique, cap it. Give it a flip. And there we go. Okay, that's our diluted solution. Now, compare the color of these two. Okay, you'll notice the dilute one is, of course, a lot lighter in color than the more concentrated one. And that's one of the ways you can tell which one is the diluted solution, which one is the concentrated solution. All right, so now you've seen the demonstration, you know how all of this stuff works. Now maybe the calculations will make a little bit more sense to you.